A die is rolled 3 times. Find the probability that the outcome is 6 on the first roll, an even number on the second roll, and an odd prime number on the third roll. Let's look at the first roll first. The probability of obtaining a 6 on the first roll, well, that's the same as the probability of obtaining a 6 on any single roll, and that would be 1/6. There are 6 faces on a die, and only one of them has a 6 on it, so the probability is 1/6. For the second roll, the probability of getting an even number, let's call that event E, the probability of E is going to be equal to 3/6. There are 3 even numbers on a die out of 6, which simplifies to 1/2. For the third roll, the probability of getting an odd prime, which we'll call event O, is given by 2/6 because there are 2 odd primes on a die, namely 3 and 5. That simplifies to 1/3. So what we've seen is on the first roll, the probability of getting a 6 is 1/6. On the second roll, the probability of getting an even number is 1/2. And on the third roll, the probability of getting an odd prime is 1/3. Now notice that these are all independent events, getting a 6, then an even number, then an odd prime, because what happens from one roll to the next isn't affected by any other previous roll or future roll. So what we can say then is the probability we're looking for is the probability of the intersection 6 intersect E intersect O. And since these intersections, the events are independent, we can rewrite this as multiplication. The probability of obtaining a 6 times the probability of getting an even number times the probability of an odd prime. So we can just simply multiply 1/6 times 1/2 times 1/3 to get 1/36, and that's the probability we're looking for.